So different parts of the circle, you can see here we've got an image. So let's start with A. Well, that's crossing the circle, touching twice. That's a line. That's called a secant. And then we got B. That's a line segment that goes through the center and two endpoints on the circle. That's a chord that passes through the center of the circle. That's the diameter. And half of that, so that would be C, would be the radius. D is just a chord, not a special chord like the diameter. And then E is outside the circle, but it touches it once, kind of like where the radius C touches the outside of the circle. That's called a line of tangent, or a tangent line, because it hits it once. And that angle between that the radius and the tangent line make at the point of tangency is 90 degrees. We've got arcs and angles in circles. If you draw an angle where the center of the angle is at the center of the circle and the two endpoints are on the edge of the circle, that's a central angle. And then you have a minor arc, which would be the small part of the circle that the central angle intercepts, and the other half of it would be the major arc. Okay. And an inscribed angle has all three points, all three vertices of the angle on the circle, and an inscribed angle is half of the arc that it intersects. Circumference is the perimeter of the circle, and we've got two formulas. That circumference equals pi d, or 2 pi r. Area of the circle is the inside region, and that's A equals pi r squared. And you can find an arc, which is part of the circle. You can find it's part of the circumference, or its arc length, and that's, you just take the circumference, 2 pi r, times how much of 360, how much of the circle that you are taking, so the central angle. And we can do it in degrees, 2 pi r times theta, that's usually used for an angle, over 360, or 2 pi r times theta over 2 pi. That's in radians. We'll talk about that in a moment. You can also do a sector. That's the pi piece. It's the sector is a region bounded by an arc and two radii. And the area of the sector is the area inside. And again, you just take the area of the circle times the fraction of the circle that you want. Got two different formulas for that. And again, inscribed angle is 1/2 the measure of its intercepted arc. Also means it's half of the central angle that intersects the same arc. Radian and degrees. Radians and degrees measure angles just in different units of measure. And we have that 180 degrees, a straight angle, is pi radians. So that helps us be able to convert between the two units. To convert from degrees to radians, we take the degrees over 1 times, well, I want to get rid of the degrees, so it would be pi radians over 180 degrees. To convert from radians to degrees, we take the radians times 180 over pi. So example 1, we want to give an example from our picture here of each kind of segment. So a diameter, well, it's got to go through the center. There's only two lines that go through the center. That'd be BC and GH. Chord that is not a diameter, so I've got to touch the circle twice, and I can't go through the center. That's only this one, so that'd be DE. A radius, we got lots of those. Just start with the center. We can go AB, AC, AG, AH would all be radii. Each one is a radius. Tangent line, we've got only one line outside and it's touching at one point C, so that is the line C. Next one, given the picture, answer the following questions. Measure of angle AOB. Well, AOB is right here. That's 56. That's a central angle, so 56 degrees. ACB. Well, ACB. That intersects the same arc as that central angle, but that's an inscribed angle, so I need to take half of 56, which is 28. Now, the next couple pieces, we're told the radius is 5 centimeters. What's the arc length? So arc length is 2 pi r times theta over 360. So 2 pi r times 5, the radius, times 56 over 360. That we can simplify. 2 times 5 is 10. Can cancel 10 and 360. That'd be 36 on the bottom, 56 on top. 4 goes into both of those, so we get 14 pi over 9 centimeters would be the arc length. Next one is asking for the sector area, so we're talking this piece of pi right here. And sector area is pi r squared, area of the circle, times theta over 360. So pi times 5 squared times 56 over 360. So 25 pi times 56 over 360, and that just simplifies to 35 pi over 9 centimeters squared. Always got to make sure we use the correct units of measure. Next one. Suppose a circle is divided into congruent slices. What would the central angle measure of each slice in degrees and radians? 2 slices, well, we just take 360 divided by 2, which is 180. Or we could take 2 pi divided by 2, which is pi radians, would be the central angle. 360 divided by 3 is 120. 2 pi divided by 3 is 2 pi over 3 radians. Divide by 4. 360 over 4 is 90. So that would be 2 pi over 4, which simplifies to pi over 2 radians. Divide by 5. 360 over 5 is 72 degrees. 2 pi divided by 5 is 2 pi divided by 5 radians. Divide by 6, that would be 60 degrees. And 2 pi over 6, well, 2 over 6 reduces to 1/3, so that's pi over 3 radians. Divide by 8, that would be 45 degrees. And 2 pi divided by 8 is pi over 4 radians. Now, example 4, a circle of radius 12 units is divided into 8 congruent slices. What is the area of each slice? Well, I know the central angle. We got that from here. It's going to be 45 degrees because we already figured out 8 congruent slices for example 3. So 45 degrees. So the area of each slice, our radius is 12, so pi times 12 squared times 45 over 360. So 144 pi times 45 over 360, that simplifies to 18 pi units squared. Arc length, again, we've got 45 degrees for the angle, so it's going to be 2 pi r. Oh, and I almost forgot, 18 pi units squared is about 56.55 units squared. Arc length, 2 pi times 12 times 45 over 360. That's 24 times 45, 24 pi times 45 over 360. That simplifies to 3 pi units, which is about 9.42 units. Because remember, it's length. Don't have to square it or cube it or anything. Last one, excuse me, takes a little bit. Line AC is perpendicular to the circle, centered at O with the radius 1 unit, so it's a tangent. The length of AC is 1.5 units. Find the length of segment AB. Well, first figure out OC. Well, OC is a radius, and it's a radius. Circle's got 1 unit for the radius, so OC is 1 unit long. OB, well, that's just another radius, so it's also 1 unit long. So we said it meets perpendicular, so this is 90 degrees. So this is a right triangle. So that means OC squared plus AC squared should equal OA squared. Well, OC is 1, AC is 1.5, and I don't know O to A. I know part of it. I know O to B is 1, but we don't know that. We can't get the whole thing yet. So 1 squared is 1, 1.5 squared is 2.25. So we get 3.25 equals OA squared, square rooted. It's about 1.8. Well, the whole thing's 1.8, and take away 1, that means AB would be just 0.8 units long. And now try the practice on your